Hello, Math 125 students. This is fall 2024, just in case I use this video in the future. I recently posted an exam for my students that isn't in the exam archive. It's from 2023. And I was about to make a video where I go through the exam, and then I remembered that I'd made a big reflection video for that. So I just went through and edited that video and took out some pieces, and this is just an intro to it. A few things about this. I didn't make that video thinking I would post it later. So, but what was interesting as I was watching it was it shows you some of the reflection. Students did not do very well in the winter 2023 exam. The stats were a little bit lower than usual. Students were kind of upset with me. And so I made a video where I sort of talked through expectations. And so it's a little bit longer video, but I go through and say, here's what you would have seen in your studying, here's how you approach. And it's not, I try to say it several times in the video, it's not meant as a criticism. And I wasn't really thinking of it as defending anything. I just wanted to sort of be constructive. So that might be interesting to you. There might be something you can take away from that if you're really worried about the test, because I give lots of tips on studying. I do a lot of stuff where I pull up old exams, and I pull up the exam from winter 2023, and I see, here's what you would have seen in your studying. So I wanted to warn you of that. So you're going to kind of jump into this video. It's going to say, it's going to be talking about reflection. So there's some commentary. I pulled a few pieces of that out. So I would encourage you to work through the test on your own and kind of grade it yourself, and then watch this video, and you can experience what those experienced students had. Many students were disappointed after this exam. And my hope is that you can have that experience now before your first exam, so that you can be a little less disappointed after you see that. So anyways, try the winter 2023 exam that I sent out, and then watch the first part of this video. Will just be about how you reflect, and then I'll go through the solutions, but I go through the solutions in a way where I compare with exam archive. All right, I hope that... I really think it's one question, which is, what surprised you about the test? So when you get your test, get out the exams you studied, kind of get out the homework, and just give me a half an hour, 45 minutes, whatever you can give to reflect on it. It's more important. I know you can look at the exam and what you missed, but I think it's more important to look at what you studied and how did that work in your preparation, and then how can you adjust to make things better. Okay, and the number one question is, what surprised me? You studied, you did all these things, and then you went into the test and something surprised you that might have made you miss things. That's the thing we want to identify and see if we can adjust. Okay, so my expectation when someone's preparing for this exam is that they would have worked through, they would have reviewed the homework, and they would have worked through several of my recent exams. That's my expectation. I would like you to work through more, but if you at least work through several. I definitely would expect everyone would have looked at my 3 most recent exams. At least looked at them quickly, and then at least done a couple in detail. So that's my expectation, is that you are aware of the homework, and you know the ideas about how to start them, and that you've looked at those. So if that didn't happen, that's kind of step 1. For the next exam, that needs to happen. Okay. And then what I'm going to do as we go through this, a few comments. And this is not criticism. This is just the reality of what it is, and we have to just be able to do this constructively. So I just want to make a comment, because I think, in fact, let's just pull up the solutions. Solutions for the most recent exam in my exam archive, which I expected everyone had looked at because it's the most recent exam in my exam archive, and the exam you took. And this might be giving away too much. But the first question you had to simplify and integrate. Now, when I was going through and looking at the grading, I saw a handful of people. Let's just start talking about the exam. So question 1, but we'll kind of do a few things side by side. I saw people integrating directly, thinking they could integrate a product and not simplifying. It's kind of like this. Did you do this test, or did you simplify? So a lot of these things, I feel like when I look at it, these are things we would experience during our doing the homework and reviewing. And so if you come and you take the test and you immediately, like some of the things I saw, not widespread, but I saw people integrating this directly. They wrote this as x to the 1/2, and then they wrote this as x to the 3/2 to the 2/3. And the moment I see that, that shows a dramatic misunderstanding. And that's the sort of thing that if we look at old tests and if we did the homework, we shouldn't be making that mistake. We should realize we must simplify. Okay, so that's the sort of stuff I'm trying to address here. There are challenges on this test, but I want to make sure we don't miss the things we absolutely should get. And that's the biggest thing that I feel like there's about 5 to 8%. When I look at those exam statistics, I thought it'd be 5 to 8% higher. And that's because people missed 5 to 8% of stuff on average that I just didn't think they'd miss. So I need to make it more clear to you that yes, you got to study my old exams and you got to know how to start these problems. Like this right away was a substitution. I know it kind of looked messy. You could do it in 2 steps or 1. You could have u be x squared and kind of work from there. But the sort of mistakes I was seeing is kind of the more mundane of doing, just not having an idea about integrating or trying to integrate things separately or integrating the x. It all comes together. Okay. So anyways, that's what this was. It was a substitution. We get this number. There we go. You might have said, well, I was unclear what to do with this 5 here. But again, if this would have been part of doing the homework and you would have seen it on old tests. Okay. This one here, we talked a lot about where, what do you do if there's a substitution? So if you don't know what to pick, you pick the denominator. And what do you do when there's a substitution and there's still an x floating around, which happens right here in this problem? We definitely did this. This came up during our review session. This came up during our discussion about this. And it's also on every old test. Let's look at this. Where is it? It's right here. Same idea. So if you had done no other studying except work through the first 2 pages of my most recent old exam, you would have encountered a lot of these issues, these general issues, and I think you would be able to start the problems. Okay, so actually no matter what, work through my recent old exams in detail as part of your studying. Know that I'm expecting you to do that. In this case, you get this x cubed. The moment there's an x cubed still here, you come back here and rearrange, and then you replace that. Now, some people have trouble with this, which I could sort of understand, but we did see lots of these things in the we saw it in lecture, we saw a couple of these in the homework. So at this point it becomes simplifying. How do we simplify? This is the same thing as 2/u. Sometimes people get mixed up by this. I remember doing the same problem in office hours with students and on the discussion board. So you end up getting this. Okay. But to me, we should have been able to start. We should have been able to know it was u substitution. There were quite a few people that got this page right as I was looking through the stats. But it's more on the order of like 1/3 of the class got it completely right. And there's a group of the class in the middle that lost 2 or 3 points somewhere in there. That's kind of that middle third. And then there's this 1/3 of the class that missed a lot of points on this page. Now that's the more concerning thing. That's those people that are in that lower quartile. So this is more of a computational thing. And I can't, I'm not going to hide it. It's a lot of integration on the next test. This is the thing you need to improve the most if you're struggling, because this is the thing you're going to do. So practice, which is what you're going to do over the next few weeks. But now you kind of know the level to which you need to raise things. Okay, so that's page 1. I don't think I'll make any more comments about that. But if you miss points, you should look at the solutions and try to understand. Now, anyways, that's the quick version of that. Okay, but definitely in the future, study my most recent couple of exams. If that's the only thing you have time for, do that first. Okay, so then we go to the next page, and there were quite a few people that missed this one. I know I didn't spend a ton of time on this. You did have this in the homework, but this was about the notation. And just sort of going back to this, if you studied, even though I didn't do a lot of this in lecture, I thought, well, everyone's going to study my most recent exam. And if they studied my most recent exam, they'll know how to do this problem. And so I was a little surprised when I realized, a bunch of people didn't know how to do the problem. So a bunch of people what it looks like to me, didn't study my most recent exam. Okay, so I think that's the biggest takeaway. is about expectations. Okay, so let's go through and talk about this one. You know, the way I would approach a problem like this was all about notation, right? So delta x is b minus a over n, xi is a plus I delta x. That's from our tick mark discussion about how we label tick marks. So what you're looking for, if you're trying to reverse engineer this, is where is the thing that doesn't have an I that's being multiplied out here? Well, that's this. And this was in your homework a couple times. That means you have this, and this means you have b minus a is 3. So that's the first recognition. The second thing is you look through the rest of the problem, and you look for this thing, 3i over n. Do we see that anywhere? And so we look and we go, yeah, I see 3i over n right here. Ah, that's right here. Is there something being added next to it? Hey, that might be a. Hey, it looks like there is something being added right next to it. That's 1. So there's more than one way to set this up, but a equals 1 is the natural choice. If a is equal to 1, then you automatically know b has to be 3. And once you know you have those two things, then you can say, okay, xi is equal to 1 plus 3i over n. And then you have everything you need. In fact, I like to take an extra step and say, that means this is the sum from I equals 1 to n of the square root of xi delta x. And then you can really see the integral staring at you there. This is the integral from 1 to 3. I'm getting that from here of the square root of x dx. Okay, so that's one of those things. Yes, it wasn't a major emphasis in lecture. Just for time, I kind of made the choice. I mentioned it when we did it. I was like, I'm going to talk about this a little less. It is in the homework. It is an old test, so do know it. But so this is something that I was expecting you saw in your studying and in your homework. Okay, so you got to know the homework. You got to study the recent exams. And again, this was almost identical to my most recent exam. So there's a big takeaway here, which is to study the most recent exam in my archive, at least that one, but hopefully more when you're preparing. Okay. And if you got stuck there, okay, it's a chunk of points. But the people that are in the lower quartile of the class, they missed multiple points in multiple places. Again, that's 5 points, which is significant, but it in itself would not have been the reason to get below 50% on this exam. Okay, fundamental thermocalculus, we knew this was going to be here. I said it was going to be here. We did it during review. It's on every single one of my old tests. So this is these named things, and during our review session I said it's going to be there, it's going to be there, it's going to be there. It's a weird special thing, so make sure you know it. When we opened this page of the book of the exam, we should have immediately written this without even thinking. Definitely something I emphasize, definitely something that's on every single one of my old exams. So if you didn't know how to start, that's a preparation problem, less than a knowledge problem. Okay, you had to know how to, the moment you saw that, I needed to take a derivative. And again, in class, we first built up to it, but then eventually we said, it's quick. You just take this, put it in here, multiply times the derivative, done. You take this, put it in here, multiply times the derivative, done, and you subtract. So that was the fundamental theorem of calculus part 1. The question then said, okay, what's the equation for the tangent line? So you had to get the slope, you had to get the value, done. But this is where most of the credit was. If you got here and plugged in, you got a lot of the credit. And that's what I thought everyone would have immediately done that first step. So this is important you see this, because if you miss that, then you go, hey, I missed a named concept. There were just a couple named concepts, which was fundamental theorem of calculus part 1, total change, and we had the tomato problems. So we had a few specific, there's a lot, the things we've done so far on this exam. This was more calculation. This was knowing about Riemann sums. And then we had a couple really special named things that I said, hey, make sure you put this on your note sheet during our review. This was one of them. So you knew it was coming. So if you didn't know how to start, that's really the thing that's hurting people's grades the most. That's what I've been trying to talk about, is make sure you know how to start these questions, and you can get most of the points and get above 70% past the course. Okay, I'm not guaranteeing that if you follow my advice that you're going to get a 4.0, but I do believe if you follow my advice, you can get above a 70%, unless you haven't taken math for 70, for a long time. You don't remember how to push numbers around, but even that you can get better at as we go. Okay, this is a problem with just to see if you could plug in the numbers correctly for Riemann sums. I did it with 2 subdivisions to try to keep it compact. I think students did pretty well on that. There's delta x. Here's how you do the tick marks. This is the first tick mark. You then add 37. You then add 37. And then you plug in. Since we're doing right endpoints, you plug in the first right endpoint. You plug in the second right endpoint. And you multiply times the width. Most students did pretty well on that. But this was the sort of the theoretical page. Again, I could see, so some people ate up time where they didn't need to eat up time. And that's part of the reason some people wrote, I ran out of time, was because they were spending time on things maybe they shouldn't have. If you look at these old tests, again, this is page 3 of the most recent old exam. I can give examples in other old exams. I'm just picking the most recent one to really make a point. That even if you just had studied that, you would have seen those things. So here's the fundamental theorem of calculus, part 1. Here's finding a tangent line. So you say, I didn't know how to do a tangent line. Well, we did in class, and you would have seen it here. Okay. So I'm speaking to we should know how to start. There's going to be places we make mistakes, but we need to get the points we can get. Hope that makes sense. Okay, so let me get to this one. This one's kind of a big one for me because I was looking through grading, and I graded a handful of these myself. Again, the way we grade is one TA grades an entire page for all students, so you know you're grading consistently. But this one surprised me simply because we talked about this not only in the review but in class. We did net change, total change. I told the dumb story about Dr. Loveless goes for a run and passes out. And the whole point of that entire discussion, and then you did it in the worksheet, was number one thing here, most important by far, is to set this equal to 0, solve, and then split up your work. That's what it is. So if I go to grade this problem and I don't see anything where the thing is set equal to 0, there's a whole bunch of people, I don't know, about 30 to 40% of the class that just tried to integrate directly. And I don't know what that's about. Could be people are just stressed during the test, they're not thinking. But this was a big, big named thing. So I'm wondering what that is. Some people just integrated directly and then evaluated, which gave a nonsense answer. The whole point of this is that if you want the absolute value of this function, it makes the function stay the same where it's positive, and it flips it where it's negative. So there is no direct way to do it, and the entire process is to split it up. That's what the whole thing was. Someone who just did these things, who did this, automatically was getting most of the credit. But if you did not find when this integrand equals 0, it's hard to give you any credit because you did not show any of the understanding. Right, so the point of this is you had to solve. Right, so I don't know how to solve the cubic. Well, if you divide it by t, it's not a cubic. There's a lot of ways we can solve this one. But you had these 2 answers. The only answer that was between 1 and 3 was 2. So this really was to me, the heart of the problem was showing this. If you did not show this, you're going to lose almost all the points. And that's a preparation thing. This is a named thing. Okay, you might say, well, it looked different. I didn't see the words total change. So I'm trying to go back to, let's see just the most recent exam in the archive. Are there any of these? Well, not that way. Let's see, right there. So if you had studied that exam, you would have looked at this problem. And the question is, did you look at that problem? Did you actually work through that? You already had to encounter this. So the studying the old exam forces you to encounter these issues. You want to embrace that when you're studying. And so you go, okay, when I see the same thing on the exam, do I know step 1? You got to be able to do step 1. Okay. And that was a big thing about understanding what an integral does and what an integral doesn't do. And then we split it up into 2 things. We get this is this area when the function's below. This is this area when the function's above. If we want to do total change, we make both of them positive. That's what I taught in class about how that goes. Okay, so the big thing was splitting it up. So if you were trying to do something more complicated, you're missing the whole idea of the entire problem. All right. So those are the things that kind of got me that I wanted to address first was the fundamental theorem of calculus part 1. That should have been immediate points, like immediately writing that down. This one, we should have immediately gotten most of the points. So if that didn't happen, you missed a key concept. And I think now you'll know when I'm reviewing and saying, you got to know this, what I mean, I hope, as we move forward. Then you had a problem where you really had to put things together and do an area. This one required you to graph. This question I took from lecture. We did this in lecture, and you had one in your homework that was similar. There was a day in lecture where I stopped and I gave this almost exact one, and I said, okay, everybody graph it. And I gave like 5-10 minutes, and everyone graphed. There were a lot of people that misgraphed it during class and left this part off, and so I thought, hey, I'm just going to keep that and then ask it again on the exam. So that's where it came from, and you did it in your homework, a similar question. It did not mention the x-axis or y-axis. It just mentioned those two curves. And so I didn't know how to graph this or this, but these are things you graphed. A line and a parabola that's on its side. Those are definitely things you graphed in the homework and in class. But even if you were confused, step one is I'm going to have to find the intersection in some way. To get this intersection, it's much, much, much easier to do in terms of y. It could be done in terms of x. But then you're trying to find this pattern. And since this time, we've done a lot of pattern finding. I saw a lot of people get the things flipped. And as I was going through, it looked like the grader was kind of generous about some of this. But really, you should have known that this was x equals 2y plus 3. And that's on the right. This should have been here. I think there's this thing happens when people see this graph. They think, oh, that's on top. But we're not thinking top. We're thinking right and left. This is bigger. If you're unsure which one's bigger, just plug in a number. If I were to plug a 0 in here and a 0 in here, one of them's 3, the other one's 0. I can tell which one's bigger, the 3. Okay. Plus, if you do the whole integration and you get a negative here, then you know where you made the mistake. Okay, that wasn't worth a lot getting those flipped, but you should have known you really wanted to use y. Anyways, I think people ate up time graphing here. So there were some challenges there. A lot of partial credit was given as well. Okay. And again, if you looked at my most recent exam, let's pull that up. Right now I'm just looking at the most recent exam, but I would encourage you to look at others when you're studying. Hey, this is pretty similar. Not exactly the same, but similar. Okay. Let's keep going. So now we've played this game a little bit of how this goes. The first page was integration. Second page was some of the key theoretical things we did. The third page, you had the total change type of question. You had to know immediately to set that equal to 0. And then an area. And then we had this big question. I mean, this is always one of the challenge pages on this test. If you look at old exams, every old exam has a page of volumes or revolution. So once again, let's go through and play that game. I think that there are, I hope that this has been improving. There are some students in the class that have their ability to geometrically reason from a graph is one thing that's holding them back. But so that's why when you do the homework, you have to let yourself do that. You have to step away from Desmos and not let it graph everything for you. Take the opportunity to try to graph. You need to be doing that in the homework. But in this case, you didn't even need to do all that. I gave you the picture. But even with that, a few people did have trouble labeling the picture. So if you don't know how to label things, you just need to combine. Okay? So when I give you something like this and I say x is 1, you could find the intersection of these two things by plugging it in. Well, then y has to be 10. That's this point right here. That wasn't part of the answer. I'm just making a comment. If you want to know, okay, well, I want to know when y is 2, you could combine these two. And that will find this intersection. So a few people had trouble with that. So 2 is equal to 11 minus x squared. That means that x squared equals 9, so you get x is 3, and minus 3, but that's the only one in the first quadrant. Okay, so you had to find those intersections. I tried to make that part quick. Then you had to find the area, and all sorts of interesting things happened here. You could do this in terms of y as well. I kind of hope that people would do it in terms of x, because you're going to do it from 1 to 3. the bottom is y equals 2, the top is y equals 11 minus x squared. So there were some interesting things that happened that I'm not quite sure, but I hope now you can go back and sort out what those were. Oh, and this is, shoot, I'm working from an old version. In the actual version of the test, I have this fixed. This is an old version. This should be a 9 right here, I think. Yes, I changed a number at the last minute. It's in the solutions correctly. I just realized that this was an old printout. So this ended up being 18 minus 9. So it was 9 plus a third. So it's going to be probably, apologies if there's a mistake here, but I think it's 28 thirds. Okay, that's in the actual solutions. Luckily, I just caught that. Okay. These two questions here, these were these revolution questions. It's all about labeling. To me, some of these things here, I know there are people struggling with the geometry, but these are preventable. This is something you could have put on your note sheet to completely know that, hey, if I haven't had a table one day in class, if I'm going around the y-axis and I'm using washers, you should know which variable you're using. You could have had that on your note sheet. But the washer method was the cross-sectional method. So you cut perpendicular axis of rotation, so the axis you're cutting across is y. So for many reasons, we should have known we had this, and we should have known we had this, and we should have known we had this before we even got started. And there are people that had some of the right form but had functions in wrong places, and those are big deductions. As I tried to warn about that, there's not a lot of partial credit here because we're trying to see that you can get the patterns. And if you say, well, I got most of the pattern, but I had no idea what the function was for the radius, well, then you don't know how to do it. So we want to get all that together. Okay, so you had to draw this. You had to rotate and realize it's a washer. So the rest of the problem is about labeling these patterns. So you need to know from here to here, that's the inner radius, and here to here, that's the outer radius, and you need those. You need them in the form x equals. So the inner radius is x equals 1. That's what this is. This right here is x equals 1. The outer radius is x equals whatever this function is. And I have that written up here. I did it as part of my beginning. Square root of 11 minus y. And you could simplify that, but that's it. Okay. If you're doing it in terms of x, then that's shells. Okay, so in that story, the radius is x. The bounds are here. And then you're trying to figure out how far it is from there to there. If you want, I can draw a bigger picture of that. So if this is x, then the distance from here to here is 2. And the distance from the bottom to the top is the 11 minus x squared. That's how far it is from there to there. And so if you want the distance between them, which is the height of this thing, it's that minus that. There you go. And the point of this next question was, okay, what if we move the axis of rotation over 3 and you use shells? Well, then it should be the exact same answer as what we just did. Everything should be the same except for one thing. So we gave people credit, even if they had mistakes in the previous part, as long as they knew all this is going to do is increase your radius by 3. It's not going to change the formula for the height. It's not going to change your bounds. But it is going to change the radius of the shells you draw. Okay. Hope that kind of helps. That is a place where people commonly lose points, but you really should have been known a few. I think there were preventable mistakes there. Okay, and I hope you're getting better at your geometric reasoning. Again, that's always on every old exam, but I do know it's a commonly missed thing, this skill. Okay. Okay, last thing is this tomato problem. And I thought the main challenge problem on the test was this one. I thought, okay, students are going to have trouble with these last 4 points. Now, that does not mean it's an unreasonable question. I don't like to give challenge questions that are completely different than anything you've ever seen. To me, this is very much like some of the challenge problems you saw in your homework, so I thought it was fair. I just thought, hey, that's probably going to be a challenge for them. The first question I thought was not going to be a challenge at all. So we got these, every time we've done one of these tomato problems, I made it just like your homework. I also have this in my old tests. We immediately wrote this. So we already should be on our way to lots of points. And then the student throws a tomato downward, it lands the instructor head in 2.5 seconds. Now, some people might say, well, I don't know the height of the instructor, whatever. But you go back and read the question. A student is standing 320 feet above their instructor. So you have the instructor. There's a few different ways you could set it up. But the question was saying that from here to the top of the instructor, it was 320 feet. So you can call that h equals 0 if you want. You don't have to. You could call it something else. But I guess that was one challenge. I did not anticipate that being. I know I did mess up a few people. But even if you thought that was something else, what you know is that in 2.5 seconds you're there. If you really didn't want to know what to call that, you could just have made up a number or labeled it. You knew initially the height was this. Okay, so you should have immediately known that this was 320. The thing you would have had to figure out was, what is this? Okay. But like I said, even if you'd labeled it differently, we still get to here very quickly. And then you find what C is. Most people did get that right. I mean, well over 60-70% of the class. But there were a few that got that wrong. If you didn't know how to start, that's the big issue. Okay, you say, well, I ran out of time. Part of the reason people run out of time is because they didn't know how to start other things. So that all kind of comes together. And then you know for the next test. But you need to make sure you give yourself enough time as you're going through and preparing, that you give yourself enough time on each page that you have the ability to write down the fundamental things. Last question. So here's the challenge question. Exact same setup, new problem though. It says a few moments later, they throw this balloon down. So you still know this is 320 where it starts. So they knew that. At the moment the balloon lands on the instructor's head, it does say it's going to hit the downward velocity. The moment the balloon head lands on the instructor's head, it has this thing. So the main thing they didn't tell us was the time. How many seconds did it take from the moment the balloon was thrown to when it lands on your instructor's head? So in this case, you want the time to when it hits the ground. So the big strategy, the general problem-solving strategy is, if there's something you're trying to find and you don't know what it is, label it. That was the hard part. That was the same thing we did in that similar question on the homework. Label it, label it, label it. Call it whatever you want. I find it helpful to not label it T, because that's confusing, because there's other things labeled T on the problem. That gives me something I can say. Okay, I know whatever that time is will be at the top of their head. I know that whatever that time is, this is what the velocity will be. That gives me these two facts. And then from those two facts, I can combine and solve. Several of you noticed that when you solve, you got 2 times, 4 seconds and 5 seconds. And some of you gave both answers, but it's not both answers. Okay, so you do need to go a little further. C is negative 16, C is 16 when I'd have this. So if the person had thrown the water balloon upward at 16 feet per second initially, then it would have come back down, and it would have eventually hit the instructor's head, and it would have looked like this. They would have thrown the water balloon upward, it would have come down, it would have hit the instructor's head. But the question did not say that. The question said it had an initial downward velocity. So that's how you knew it wasn't that one. It had to be this one. So the answer had to be 4 seconds. Okay, I hope that kind of helps. I hope you do the survey reflection. The main thing I'd be looking for is things you can do on future exams to get yourself more points. Do you recognize, I think the biggest takeaway is, did you look at the most recent exam? If you just want a particular thing. Did you study? And it's really helpful to do this. Just hold the exam up next to just the most recent exam, just to pick one. And you go, okay, did I study this question right here? Did I miss the same type of question on our test? Did I not know how to start? Did I study this question? Did I miss the same sort of question on our test? Okay, I think that starts to make things real, and sometimes that's the key people need. So in the future, and it's not just one test, I would definitely look at the most recent couple. When you did the old exam, did you do this? That's kind of similar to part 1B of our exam. Did you do this? This is very similar to 1C from our exam? Did you do this? Same, almost identical to the total change problem. Did you do this? Fundamental theorem of calculus. So now when you go back and look at these exams, there's a tomato dropping problem. It becomes more real that, oh, he is going to ask these questions. I need to know how to start them. Okay. Hope that helps. Again, these always come off as negative, but my end goal is to help you for the future exams. The goal is improvement. Nobody's doomed to a low grade. You all can still do great in this class, but now is the time to reflect on what you can do till the next exam goes better.